Hello, everyone. Welcome to Learning Activity 4 System Dynamics Lab. And we're going to jump into making a model using Loopy. We're going to do a CISO model and we're going to do a MIMO model. And so the first thing you want to do is jump out to Google. So www.google.com, and then you come out here. And then if you type in Loopy like this, just like that, it's not Loopy Cases. It's not that one. It's Loopy, a tool for systems thinking. And Nikki Case, incase.me, is actually the owner of this, and it's actually a really great tool. It was featured on Y Combinator and was built using that. It's actually a really great tool, not just for uh, uh, us here at the college level, but it's actually very useful across different K through 12, as an example. So first things we're gonna do is you can check out different models here. You can play with an example, or we can make a model from scratch. And that's the easiest thing to do is we just go over here and make a model from scratch. And you're gonna have this space to work with that we actually can do a lot of different things here. So I'm going to get you familiar with the tool set, and then we'll go straight into it. It's very straightforward. You got 4 controls. You got a pencil, text, and you got the move, and then you got erase. So if you're going to create something, you draw on this workspace anywhere here. So if you draw a circle like this, it creates a node. And then if I create another circle, it's a node. And then if I draw a line between them, um, it creates a connector. And I can change over here on the right. And if I zoom in just a little bit, I can make it a positive or negative relationship. Remember, we talked about negative and positive feedback loops. Well, we can model that actually out here. Um, and then I can add text, and then I can use the hand to drag stuff around. It's pretty straightforward. I can do a lot of real simple things. I can also erase. I can come in here and erase all my stuff. I can come in here and see I can erase everything. But if I come back here, I'm going to create a node. So to create a node, we just create a circle using that. And then I can come in here for this node. I can describe this node as, say, input, like this, and I can give it a color, and I can say input is blue, and I can start the amount, and then I can say the amount of the node. In other words, how much is in it. It'll make sense once we play the simulation. And then I'm going to do something simple where I'm going to have an input, and then I'm going to have an output, and then I'm going to link these two. And then over here, I'm going to say, so I select text, and then I select what it is that I want to change to, and then I can go input, or output rather, output. And then I'm good to go. Oops, I don't need that. Okay, so I can hit the erase, and I accidentally put a text in here, which is fine. There's nothing wrong with that. And then this is good for annotation. So most of what you can do is using the move function. So if you come in here, this will always be able to get you just about everything you need. The menu on the right here allows you to, each time you use the move feature, whatever you select, you can actually adjust in the menu what that element does in the model. So on the input, I've made that blue. Let's make this green on the output. And then here, I'm going to say it's going to be positive. So anytime I have a positive, it's going to, and this is a single input, single output situation. So once you have this drawn, let's just play with the model here and see what happens. I'm going to hit play. And then you're going to see these up arrows and down arrows. So I'm going to add an arrow here. And what happens is it's going to, every time I add, it's going to it's going to create more of the output. So for the input, I add, and then it's going to create more output. Now I can take away, I can put a negative, and what it's going to do is it's going to decrease. So like this. So this is what is called a proportional proportional relationship. So for every one that I create, a one is there's a proportional growth. So there's a correlation between I add one in the x plane, I get a one in the y plane. So for example, if I'm going to stop it here, and then this is what's called a uh, positive relationship. And then this is a proportional relationship. We'll just say proportional. There we go. That's easy. So again, for every positive, I get a positive in the input and the output. Now, let's do the same thing, and then let's see what happens if I create another one. And then I make this same thing, input. I can even simplify this a little bit. I can say I'm going to create a relationship between two. So for every input, I'm going to, for this one will be positive, but then this one will be negative. So what I'm going to do is I'm going to come over and I'm going to make these kind of similar. And then this is going to be growth, and then this is going to be red, and this is going to be output also. But this will be a negative output, and then this is going to be positive output. Okay, positive, perfect. Okay, and so what'll happen here is for this, I'm going to make this one, I'm going to make it full. I'm going to make this one small, and then I'm going to make the input here small also. But then what I'm going to do is I'm going to change this to that. I'm going to make it a negative relationship here. So let's see what happens when I push play on this simulation now. And I guess I should probably stop it and then come over here. And then create another text one down here. And then this is going to be negative relationship. And so the opposite of proportional would be non-proportional, non-proportional relationship. And then we will go here, and I think we've got what we need on that. Okay, so let's go ahead and run this, and then I also remember what we should call this, which is an inverse relationship. But I'm gonna say non-proportional for right now, and then we'll make an adjustment. So let's push play, and so what's gonna happen here is you're gonna come in, and we're gonna do the same thing we did before. So when we add an arrow in, what we're gonna add an arrow, what'll happen is it's going to create a positive line, a positive relationship here. And then it's going to start off positive, and then it's going to switch to negative on this. And so this is going to increase, and then this should decrease. So let's go see what happens. So there we go. We get the flip, and boom, there you go. Let's do it again. And there we go. Flip and boom. So then what happens is the input goes up, and then this increases in relation, so we get more. And then the negative output, it was full, and now it's decreasing, so that when we come in here, and then if I keep doing this, I add in a couple more, right? What's going to happen is it just keeps making it smaller and smaller, and this fuller and fuller. So that is by definition what a positive relationship is and a negative relationship. So I'm going to come over here and call this an inverse relation. That's the better way to call it. That's the more technically correct word. So that's a proportional, that's an inverse. And now we can that's pretty much it. I mean, that's all we need to do. Now, that's the high level. Let's talk about creating a simple CISO. So in a simple CISO, I'm going to come over here, and then this is a CISO cruise control. It's a single input and a single output cruise control system. All right. So I'm going to put in speed. So our input is speed, and our output is really speed maintenance. It's speed, but we're maintaining speed. So we'll just say set speed and maintenance speed. So we'll say set speed, main speed. There we go. Okay. So here what we'll do is we'll say set speed, and then this will be maint speed. Okay. And that's all we're gonna have here. Now we'll push play, and then essentially all we're gonna do here is I'm gonna speed the car up, and then what'll happen is and this is all relative. So and then that's it. So I've set the speed, and then I'm maintaining the speed. But I want to go faster, so I want to have more speed here. I'm gonna make this go higher, and then I want this to go higher even more. And then what happens is it maintains that speed. Now, if I want to decrease, I'll send a negative, right? And then I'll have a proportional decrease. So the positive doesn't mean I'm sending a negative or a positive. What it means is that every time I send a positive, I get a positive. That's what we mean by proportional. So if I send a positive, then I'm going to get a positive. If I send a negative, I'm going to get a negative. That's what that means. So then I'm going to have a negative, and then I send a negative, I get a negative. There we go. And that is the definition of a cruise control system. Simple, easy, straightforward. Now, I am skipping a lot of stuff because a good cruise control system actually is more, modern cruise control systems are more than just CISOs. They're actually a lot more complicated now, especially when you have radar and radar following to maintain speed. A lot of modern cars now, you set a cruise, but then it's not just maintaining the speed, but I'm also paying attention. I have multiple inputs now. So it's a multiple input, single output. So modern cruise control systems are more like MISO systems, multiple input, single output. In other words, I will use my normal cruise control system to maintain speed on incline and declines, right? But then I'll also use radar systems to do a radar following with the car in front of me to maintain my speed, in addition to my normal cruise control, which means I have two inputs. I have my following distance between me and the car in front of me, as well as my ground speed. So there are new, more modern cruise control systems are anyway. Where I'm going is they're more than just simple CISO systems. Okay, so I'm going to stop here. That's a CISO. So I said that I would do a CISO. Now let's do something that's more complicated. Like, okay, let's take this and really scale this up and really get into something fun. Okay, so we're going to create we're going to do a plant growth simulation, and this can get a little crazy. So let's delete everything. So I'm going to go over here. I'm going to delete. Okay. So let's go ahead and start off with a plant. We're gonna do a couple things. So for a plant, I'm gonna need sunlight, and let's move. So I'm gonna need some sunlight. We'll put some sunlight, and then we're gonna say plant growth. So I'm gonna say plant growth, and I'm gonna say sunlight. So this is gonna be sunlight, and this is going to be plant growth. So we all know that sunlight is required. So I'm going to take the pencil, I'm going to draw it over here. So I definitely have to have sunlight for plant growth. And we know that there's a proportional, in other words, I have to have sunlight for the plant to grow. So we know that an absence of light also means that plants don't grow. And I don't want to make it complicated by talking about algae and stuff like that. or deep water hydrothermal vents and vegetation that lives in the seas. Let's just keep it simple, and we'll talk about your everyday corn that grows out in the field. So we got plant growth, and you got growth in your field, and you need sunlight for that plant to grow. Okay, so it's a positive relationship. If we push play, if I take sunlight away, then I'm not. Oops, I'm. Let me stop. I've got a negative here. So come over here, and this should be a positive. There we go. All right. So now push play, and then if I take sunlight away, then I don't get plant growth. I take sunlight away, and then I don't get plant growth. That's perfect, right? It's a simple system. If I send sunlight, I get plant growth. Very simple. Okay, but we know that plants don't grow just based off the sunlight, right? So we got to model something extra into this, right? So, all right, so we know we need water. So water does impact. So water is has a positive relationship to so let's model this out. Water has a positive relationship to plant growth. And so it's positive, and then this is water. All right. And so now, but water I mean, yeah, that's fine. So I'm going to start this out at the low end here. So I'm going to make the amount. I'm going to send these all to small. Okay. So I know that if I do this and I do this, I'm going to get plant growth, right? I need both. Um, but if anyone's kind of running through this, they kind of know that it's not that simple, right? It's not this simple. That I mean, we want this system to be autonomous. So we want this to be an autonomous system with a feedback. So let's stop, and then we'll kind of sit here and think through this a little bit more. So what else do I need for my weather pattern here? So I need a weather pattern. So let's create weather, because we know that the sunlight and the water are both affected by water. So I know that I get water from weather, but then I also know that the sunlight affects weather as well. And I'm going to stick with them being just for right now. I mean, there's no way to model this relationship in anything other than just really high level. So what we're going to do is this is going to be weather. And so this isn't bad. This is starting to look interesting. So I'm going to push play on this, and I'm going to hit sunlight, and then I get weather, water, plant growth. Okay, great. So then I keep doing this, and then I keep, but I'm still kind of, I don't have a feedback system. It's just a one-way system here, right? If I take away sunlight, then that's a decline in weather, and then that's a decline in water, and then that's a decline in plant growth. So that's okay, but this isn't getting me where I need to go. So water is also affected by. Let me stop here. So water is affected by soil, and I'm going to call this soil. And then I'm gonna give this yep, and then water. The soil is affected by evaporation. We'll just say evaporation, and then that should show us yep. And then I can draw a relationship to water soil, and we'll keep it positive. And then soil evaporation, that's positive. And then we'll keep it positive as it relates to weather too, because we know that these are tied together. So already we're starting to get into something that's a little complicated, right? So if I push play on this and then I hit 1 for sunlight, and let's see what happens. Now I'm starting to get some feedback going, right? But it's not, remember what we talked about from earlier? In earlier lectures, I had this thing that I was talking about when as it relates to stability. There's no stability in this system right now. I got something happening here, right? But water, soil, evaporation, weather, and out of control plant growth. There's nothing that's checking plant growth. But sunlight is kind of weird because the weather pattern and the water system and all that is in this kind of echo chamber right now. It's this self-fulfilling prophecy. So it's like talking to yourself and propping yourself up, or listening to the same news over and over again without getting any external news from anywhere else. You're gonna get, it's just this self-fulfilling prophecy where you're just kind of sit here stuck in this endless loop cycle. So, what do we have to do? Well, we got to create a feedback system that helps to desensitize or de-emphasize what's happening here in this loop that we're caught in. So there's a couple things. One is we don't have any growth on the plant. We don't have any mitigation to control plant growth. But then the other thing here is there's nothing that's controlling the sunlight, because if any of us are familiar with how this works, um, the Earth's rotation, right, has a direct correlation to our weather patterns and plant growth. So in other words, we don't always we have this rotation of sunlight. So sunlight comes in and sunlight comes out due to the Earth's rotation, right? The Earth is round, it's not flat, and the Earth rotates. And as it's rotating, we get sunlight, and that sunlight helps to bake the planet when we need it and then give it rest when we need it. And then our life ecology systems have evolved to take advantage of this, right? So now what we need to do is we need to create something that's Earth rotation. So, but this is kind of cyclical. This has some kind of, there's a give and take that's happening here. So we're going to create a positive and a negative. We're going to create a feedback loop between the sunlight and Earth, and we're going to call this, we'll call this one, we'll call this Earth rotation. Let's be more specific. Rotation. We'll make that blue, and then we'll come in here, and then all right, and then we have to make one of these negative. So I'm going to come over here and make this one negative, and then this is going to give us a little bit more to work with. I'm just kind of making some room here as we start to kind of play with how this is going to work, right? So as the Earth goes, moves around the sun, we get this rotation. That's not actually how that's going to work. But anyway, okay. So now what we should have is a interplay of sunlight that ebbs and flows within this dynamic simulation that we've created. So let's push play, and then what I'm going to do is I'm going to hit the Earth rotate. I'm going to set the Earth in motion and rotate. So then there we go. I'm going to slow this down a little bit and see if we've got a system that's a little stable. And oh, by the way, you can speed it up or you can slow it down. So I'm gonna do this, and then I'm gonna let this kind of move along, and then see if we do have some stability here. And you can see just by adding in Earth rotation and managing the sunlight coming in and then the Earth coming out and the sunlight going down has already started to have an effect on the, you see that I have evaporation and then the weather pattern, and then I have air. So water is is being absorbed in the soil. The soil is evaporating the water. That evaporation is getting into the weather system by creating more water, right? The sunlight is driving the weather system, right? And again, this is high level. And then that is creating plant growth. But as you see, I still have a problem though. As I've been talking, you notice that we had the system was more stable. But you'll notice that I'm back to over too much plant growth. So I still have a problem. I still have too much plant growth. Well, the interesting part about this is what else can we add in to help stabilize this system when it comes to sunlight and plant growth? Well, animals, right? We know that animals, humans, and we're just going to lump us humans in with the animals. Humans consume plants. So, what's a way for us to limit plant growth? Well, we can create this animal bucket. And then this animal bucket, we'll say is purple. And animals consume plants. So that's a negative relationship. So in other words, for every animal we've got, there's going to be an inverse effect on plant growth because we will consume plants. So let's draw a relationship to that. But also, there is a relationship between water and animals. So animals need water. So we do need to have that. So that's a positive here, but it's a negative here. So so negative is good. Oops, and then let's change this to positive. And you can see we're starting to really crank out some interesting things here, all centered around water. And let's just kind of see what we get right here. And I'm going to now say play. And remember, what we're testing is we're testing for plant. So we've built out our model, but what I'm trying to solve right now is perturbations in the system, or what we call ecological perturbation. But there's a perturbation right now. In other words, there's an ebb and a flow to the system that we're building here and that we're modeling. And this all started out with something simple, right? Plant growth, sunlight as it relates to plant growth. And then now we're kind of really modeling this stuff out in some detail. And we're trying to apply we're doing stability analysis is where I'm going. So because earlier in the first couple of cuts, plant growth is out of control. That means I am not adequately accounting for something. We can't have out of there's something that is controlling plant growth, and so I'm putting a control in to mitigate the out of control plant growth. So this is us using stability analysis and then applying a systems design approach to this dynamic model. So in other words, so let me back up. We're taking a systems we're doing stability analysis right now in application to a systems design, and we're creating a dynamic system model. So let's go ahead and kick it off, and we'll see what happens. So I'm going to do this slow, and then I'll speed it up because I just want to see what it does here. So sunlight's going out. I've got my relationships, my evaporation. I've got my water supporting my animals. And then I've got my water also supporting my plant growth. But then I also have animals with a negative relationship as it relates, an inverse relationship rather, to plant growth. And so far, I'm getting, it looks like, yeah. So as you notice here, I'm getting some negatives that are coming through to manage this, right? If you look, I've got some negatives that are coming through that are limiting my animal population now. So this is a nice bonus. So what's happening is and if you really analyze this faster and faster, I've got a lot of negative that's bringing the animals down. I'm also controlling for animals in this relationship, and my plant growth seems to be stable. But interestingly enough, my animals seem to be in a stable state too. I have an ebb and flow, right? Because animals, they grow and they die, just like plants, they grow and they die. And so there seems to be, just from this natural Earth rotation from Earth to sunlight to this, I'm starting to get a management of that. So now here's what's happening though, is I've got too much going on here. I've got water, weather, evaporation, soil, just from the rotation. I don't have any mitigating effects on really, I think, what's happening on my water. So I think as you see what's happening here now, I have, it's still, we're getting there. We're getting closer. So I do have some, but it's not quite stabilized yet. So what else can we do to stabilize the system? So let's go ahead and stop and then see what we can do. So I think one thing we can do that we haven't accounted for is that sunlight can increase the evaporation. So we can create a negative relationship for every time sunlight is expanded on throughout the day, it increases the rate of evaporation. So I think that's the one last thing I want to do and add on to this, and then we'll see what it does to help kind of balance the system. And let's see what happens here. Okay, so I'm going to create a relationship between evaporation and sunlight, and then I'm going to make that a negative relationship, and then I'm going to come over here. All right, and then just kind of clean this all up. And then I think at this point, let's push play and then see what we get. So I'm gonna kick us off by rotating the Earth. So we're gonna start Earth rotation, and then we'll see what happens. And so this is gonna create sunlight's gonna create our weather, but then it's also gonna have a negative impact on. It's gonna have an evaporative effect, an increased evaporative effect. And so we'll see if this helps to balance the system out. And so far, this looks pretty good. I'm seeing a lot more control. Yeah, I'm seeing a lot more control. Because what we're looking for here is that we have plant growth that's under control and animals that are under control, right? And so we're checking to see if we've got maybe too much. We're going to let it go and see what ends up happening here. Because over time, what we're looking for is as the system starts to run, and we can speed this up, right? We can just kind of do this and then see what happens over time. So everything looks pretty good. But the problem that I see now is that nope, that looks okay. Nope, I see, no, I spoke too soon. So now I think we're in a spot where plant growth is now coming in and out. It's as this is moving, it's a little bit more, it became a little bit more stable, right? So I'm going to slow this down. But I still kind of have a system where I have too much going on here. And so what I could do is we could add in additional weather effects on soil, right? So as weather can have a negative effect on soil. And then we can see if that helps to maintain more stable plant growth. But as I'm talking through it here, you can see that I'm actually doing pretty good with this model so far, where I've got animals a little bit better in this model where I've got some hammering out to do in terms of water, soil, evaporation, in this aspect of it. There's of course some additional aspect. There's additional relationships you could create in this whole model. Like I was saying, like weather has an erosive effect on soil, so you could put that as a negative. You could put water also has a negative. It could go back and forth, right? Like water is absorbed by the soil, but soil has a detrimental effect on water. You can model this a lot of different ways. This isn't by any means, this isn't the only way to do it. But what I'm going to ask everyone to do here is, because we're at the 30-minute mark, past the 30-minute mark, is what would you do as you start to build this out? I encourage everyone here to start to build out what they think might be their model to help control and make this a stable system. Because there's still some things that could be done, right? Animals are kind of out of control. We've kind of stabilized for plant growth with this model, but we don't have any predation on animals, right? So there's so you could put some kind of animal control, where you could say through natural predation. You could put a note out here for that, where it has an effect on animal behavior and the growth of animals, and that would be a limiting factor on plant growth. That would certainly help in this whole paradigm we have. So With that, I think that's all I'm going to cover for now. I really appreciate it. I hope you enjoyed this dynamic model. And again, feel free to make adjustments to it and learn more about modeling dynamic systems. And this was a fun exercise. So be cognizant of this. We're going to be using Loopy more. It actually has a lot of applicability. I would highly encourage you to be thinking about. We'll be using Sage Modeler as well, but as part of your project for this course, your team project, you'll want to pick either a Loopy or a Sage model. So we'll be diving into Sage Modeler next week. This week is going to be just focused on system dynamics, and then next week we'll be focused on Sage Modeler, and then we'll probably explore some use cases between the two. But anyway, as you think through your system and your project, I want you to be thinking about the dynamics of your system, as every system has a dynamic to it. Okay, I'm done talking. Again, I appreciate it, and I will see you in the next learning activity.